Hello, I'm Chris Howard. I'm one of the founders of the Explodey Company. We are a company that's looking to do a lot of really interesting things for helping define the next generation architecture for big data systems. The talk today actually does a very interesting job of dovetailing off of Lee's discussion a couple of slide decks earlier. And it's really all about how we're in a world of huge amounts of data and little networks, and we have to start thinking about the way we deal with our data a little bit differently. So, for example, look in your pocket right now. You probably have something in there right now with a camera on it that can produce data streaming at about 72 megabytes per second, the little camera right there. And best case, your network that connects to the outside world is probably running around 4 megabytes a second. And that means that you have to do a huge amount of data reduction even before you can shove that out on the network. And typically, you have to do a lot more than that just before it even gets to the internal storage of the device, much less getting it to a system that can process that data in real time. So you're in a world of huge data and little networks, and that's just one sensor on one device, and your cell phone has about 15 or 20 other sensors attached to it. Now to kind of scale this up to a different thing, and actually to kind of extend that point right now, over 99.5% of all data is not being effectively utilized. And that really dovetails on the whole entire 8 exabytes of data that's being generated per day. Most of that data is in the embedded or automated systems world, and that data is generally used once to do something like keep your engines running, maybe a few bits per second shoved to the dashboard or to some sort of metrics black box, but for the most part, that data is used once and thrown away, and there's lots of interesting things you can do with that data that isn't directly out there. So for example, your automobile, if it's been released in the last 5 years, probably produces somewhere on the order of 25 gigabytes of data per hour across over 200 sensors that are all under the hood trying to do interesting stuff. Again, that data is generally just used once, and then by the control systems to keep things running or run the ABS brake system correctly, and then the data is thrown away. But if you were to do interesting things and actually aggregate that data across multiple cars or across a fleet, you can start to do a lot of really cool science and math, such as do things like distributed air quality monitoring, predicting localized weather, surveying road conditions, like figuring out the point right before a road's going to freeze, or doing crazy scientific stuff like measuring cosmic ray activity across a large geographical region, because you effectively have a mobile sensing platform that you can do a lot of secondary, really cool stuff yet. Remember, it's not just phones and cars that have these kind of things. Everything from toasters to cell phones are getting IP addresses and are pushing data to the internet. And no one really has a good answer for dealing with this data except for setting up a whole bunch of stovepipes to do one particular type of analysis at any given point in time. And to further complicate this factor, we're only getting more sensors in the world. The amount of data that sensors are collecting is going up at an exponential rate. And the networks to actually get this kind of data to where it can actually be utilized in a data science environment are at best increasing at a linear rate. And so therefore, we have to start thinking very differently about the way that we apply our algorithms to the data and where they have to be deployed in order to do things effectively. So when you start to look at how these devices looks internally, don't worry about the details of this, but basically when you take the hood off these devices, this is the kind of stuff you get internally, where you get a whole bunch of algorithms that you want to be able to run on these devices, and a whole bunch of sensors that are doing things against those environments there. Some of that processing is occurring attached to the sensor, some of it's being done on the platform, and then somehow that data has to magically make it back to the algorithms. So finding a way to move the right side to the left side in a way that doesn't require a whole bunch of embedded computing degrees is really where interesting things will have to happen in order to do things effectively. So when you start to look at this in terms of large-scale architecture right now, on the right is more or less, or I guess to the left from your perspective, is how things look like more or less today, where you have the data science model that generally works very well for things that are generated with web data, for things such as internet search or, or web analytics or business intelligence. It works really well for the types of data we have today, because you're usually able to capture that data from where it's being generated and be able to put all that data onto disk where you can kind of process it, do data science at your leisure, mostly using batch processing. And where the batch processing isn't quite fast enough, you can start throwing streaming techniques at it using Storm or Spark Streaming or whatever you want to be able to do. Or have to do some processing as the data is coming in off the wire. But by and large, this is good enough for most of the compute today. But as soon as you start to consider this huge amount of sensor data and sensor data networks and being able to do effective things with the billions of sensors that are being deployed out there, you have to really start thinking about everything streaming all the time. So you really get to a point where you have to think about things that are more on the other side of the chart. So in this case, going forward, your streaming environment will be your primary source, and even on your centralized processing environment where you're putting that information, your streaming will be the most important processing environment, and that will be supported by the traditional batch computing system that you probably use today in a very similar manner. Just the streaming portion of that is going to vastly expand. And where you get to the point there is that really, and the networks that are attaching this data that's getting to your central environment are always going to be much, much smaller than the actual data you're going to be able to collect. So you have to think a lot more intelligently about what processing you're doing at what point in the cycle, and what type of data science you're able to do at certain points in this environment. And thirdly, you have to kind of think a lot more about what components you're actually able to get back to your centralized data processing, so you can do your traditional data science type activities for things that you cannot necessarily do for doing things like data science in the streaming world. So really, we're getting to the point where the world is going to get a lot more complicated, but when you're thinking of it in terms of this competition, what it comes down to is that take the application that you're building right now, and how would you architect it differently if you assume that you had to do most of that processing in the streaming domain as opposed to the batch domain? What could you do differently if you're pulling data that was streaming off of your vehicles, off of the CDOT sensors that are along the highways, off of the cell phones that the users are carrying in their pockets? And what can you do with that kind of data if you were to do that with very low latency processing? And what interesting things could you do when you think about working with that data in the streaming domain as opposed to working with just the data that you may already have preformed batch on disk that is already being collected for you? And that's really going to be where a lot of the interesting things and new applications are really going to be forming in the future. So in short, right now, sensors are everywhere. There's a huge amount of untapped potential with things that are out there right now, and we're only going to get exponentially more sensors out there in everything that consumers buy, and pretty much every piece of industrial gear moving forward. And unfortunately, bandwidth will always be limited, so more and more we're going to have to think about bringing processing to the sensor as opposed to as opposed to bringing data to the actual compute. So really, it's thinking about big data in the same way that you would have. So instead of bringing your data to your compute, you bring the compute to the data. And so it's really this similar model, just your architecture is slightly different. And again, most processing decisioning moving forward will have to occur in the streaming domain to make the timeliness that people are interested in working with to do very interesting things. And you also have to use that same type of model to be able to reduce the data to the point where you can fit it over the network, so the data is where it needs to be, when it needs to be, to do the type of operations you need to be able to do, or the data that needs to be archived for perpetuity so you can do data science or charging or whatever else you need to be able to do with it. So what this really says is that the current shortcomings of big data are going to become a lot more pronounced moving forward as this data moves forward, and especially when you start to look at the infrastructure insanity, 3-month upgrade cycle, can't move data workflows easily between platforms. Everything is stovepipe, or even the Amazon stovepipe, the Google stovepipe, the IBM stovepipe, nothing is compatible. And it's even worse in the IoT world right now, where every single company has their own IoT custom thing. So really, these portability and non-modularity of big data systems are only becoming more important and complicated as things move forward. But if you get rid of those little details and kind of look at how you want things to actually look like in the real world, I didn't know that was animated. It looks like you want, as a developer, to look like this. You want to be, as a developer, to be able to develop a really cool algorithm or workflow, be able to throw it into some sort of capability catalog, and then later either you or an integrator can come in and combine most of those capabilities into some sort of workflow and then deploy them onto the hardware to do your thing. And if the hardware if the hardware is telling you that something interesting is happening, you can very quickly and easily swap out components, retune parameters, and redeploy a workflow. So from your perspective, you can abstract a lot of these things away from your thing. So, and this is really where big data is going to be going once it really gets mature and powerful. And really, when you can get to that point, you can do a lot of really cool things and make things a lot more shareable and open and good. So yeah, it looks like I'm out of time right now, but if you've got any, feel free to contact me using the contact information on the website if you would like to have any further discussion. Thank you.